Hi everyone, and welcome to our second part of our Biocontrol Regulatory Masterclass series. I'm Alison Watson, I'm moderating the session again, and I'm joined by Roma, our expert in biocontrol regulations. She's back again, and also Putra is going to be helping as well, who's our project assistant on this project. So it's really good to see lots of familiar names. If you haven't already, please jump into the chat and introduce yourself. Great to sort of tell us where you're from and just share a little bit of something interesting as well around what you're working on. I can see there's lots of different people from lots of different countries as well, actually all around the world. So we've already got 60 people online, so that's fantastic for the session. If we can move to the next page, Roma. That would be good. And it's just reminding everyone, I'm sure people don't need a reminder, but we're just using the chat today to really ask all the questions and introduce yourself. And if you want to share any resources, please do so. Lots of people did that last time. That was really useful. If you have any questions, please ask as many as possible. Even if you think they're silly, there's no silly question in this area. So I would just get in there and take the chance to ask an expert and actually find out what other people are doing in your area or across the world, across this region in Southeast Asia and the Pacific, and share your thoughts and expertise as well, so we can all learn together. Just moving on to the next slide. Also, if you do want to talk, you can put your hand up and we can unmute you. So once again, please just introduce yourself in the chat. And if we move to the next slide, I'm going to even go quicker, because I just want to remind you that, next slide, please, Roma. Yep, that's it. So this is part 2, human safety. Next session, in 2 weeks' time, we're going to take a short break, will be environmental fate and ecotoxicity. So that will be an excellent session as well. And I think Roma's going to actually leave some time for a lot of his questions as well, and sort of a summary of the 3 sessions, so everyone catches up and is on the same page. So I will send a reminder. I was a little bit late, sorry for sending the reminder this time, but I will be sending it now that I've got a week's break, probably at the end of this week, early next week, with the recording from both sessions. So moving on to the next page, and before I introduce Roma, I'm just going to do a poll. We've already got 70 people here, so I'm going to launch this poll, and it's really just to ensure everyone's up to is joined, but also just to find out a little bit more about each other. So hopefully you can see that. There we go. No right or wrong answers here. It's really just to warm you up, make sure that you're awake coming into this session, which will be quite intensive, I know, because Roma always has a lot in store for us. No rests for us, I think, is the summary of Roma's presentations. So the first question is, what best describes the work of the organisation you work for? And I'm sorry, I only give you one choice. You really have to kind of maybe even choose sometimes if you're one of those blended organisations. And did you attend session 1 of the Biocontrol Regulatory Masterclass series? Here we're just interested to know who is new, who's joining us as well, and those who have come back. So we've already got quite a few people. Oh, wow. Yeah, quite a few people have already answered, actually. This is good. And I'm sorry if you're attending via a mobile phone and you can't do this. I think that may mean that you can't participate in the poll. I know we had a few problems last time, but we've already got 68%, so I'm going to leave it, probably see if I can get one more person. If there's one more person out there that hasn't answered the poll, please do so. Oh, there we go, that 49th person. Congratulations, whoever you are. I'm going to end the poll, and I'm going to share the results just so that we can get a bit of idea of who you are. We've got 56% from government, excellent. 15% who identify with innovation, and research for the organisation is 29%. So that's actually a really interesting mix. And pleased to see lots of probably regulators there from government attending. Did you attend session 1? Look, we've got 71% yes, but you've got some newbies in the room as well, Roma. So that's good, because she's going to start, I'm very sure, with a bit of a recap from the last session, just to sort of bring you all up to speed before launching into this really important topic on biocontrol regulation and human safety. So that's a big thanks for from me for joining us again, and a nice introduction now to Roma, who really is an expert in this area. I'm not going to give you a big introduction like last time, but we're really pleased to have you with us, Roma. It's really is a pleasure, and we learned a lot from the last session. So thank you for coming back, and we're really looking forward to hearing what you've got to share with us. Thanks.
Thank you, Alison, and Putra for helping to organise today's meeting. So, and welcome back those who were here last time. And then for those who this is your first session, I'll do a little bit of recap at the beginning of this, but these sessions are recorded, so you'll be able to go and listen to that session to catch up a little bit. So there may be some things that I'm saying today that may be a bit puzzling, so go and listen to the first session, and hopefully that will help you to sort of understand where I'm coming from. So in today's session, it's a much narrower focus, and I'm just thinking about human safety. And I wanted to do this because with the technologies we're talking about, it's not necessarily easy to think about what we're doing. So when we're talking about registration for times, looking at how long it takes different countries, what we discussed last time was that in some countries that have adapted their regulations for bioprotectants, we see that the regulatory process takes a lot less time. And what we're trying to do by thinking about what you need to do as an applicant and as an evaluator for these technologies is, by understanding the technology well, understanding how the regulation can be adapted, we're aiming to keep to the shorter timeline so that we can allow these products to get into the marketplace, because farmers need them, and they need them very quickly. And so our aim is to see, can we bring the timelines, make them shorter, because everybody in the process understands really well what they're trying to do and understands the technology. So just to recap the technologies that I'm talking about. So there's usually 4 technologies considered as bioprotectants. They can be called biological technologies or biocontrol solutions. But when we're talking about registration as sort of plant protection products, as pesticides, we're really talking about 3 groups of substances. We're talking about microorganisms, botanicals, and chemochemicals. And so my talk's going to focus on these groups, and I'll talk about them in that order. That I'll talk about microorganisms and what we have to do to adapt regulation to them, botanicals, and then finally with chemochemicals. So just to remind ourselves that the markets for these technologies is growing really fast, and we've got a lot of interest from growers so that they can practice IPM, and these kind of bioprotectant technologies are a really important tool, if not one of the main tools for implementing integrated pest management. They're also really useful tools for resistance management and residue management. So what we see is there's a lot of push for people to get hold of these technologies, and farmers wanting to work with them. And the basis of what I'm talking about and the regulatory process we're following is documented really well in the WHO FAO guideline for the registration of microbial, botanical, and chemochemical substances, and that's both for plant protection and for public health uses. And the aim of this document is to ensure there's a high level of protection for human health and the environment, but ensure there's no additional registration barriers. So that goes back to me saying there's no reason this should take longer for a bioprotectant than it should for anything else, and can we even do it faster? And also to think through, can we take a more simplified approach, and what's the rationale behind that? So when we think about a synthesized or conventional chemical pesticide, these are mainly substances that have never been found in nature. So we as applicants and we as evaluators, we have to be very, very cautious, because we're not entirely sure what's going to happen to those substances. We're not sure what the effect they'll have on humans. We're not sure the effect they'll have on the environment. But a lot of the things that we're talking about that are used as bioprotectants, we do know something about them. We know that they do occur in nature. So we know that the microorganisms came from the natural environment. We know that the botanicals came from the natural environment, and the same with chemochemicals. They may be synthesized, but they're mimics, they're copies exactly what's in nature. So the question then is, because we know that, does that mean we could take a slightly different approach to them? And that's the question that this guideline from the WHO FAO looked at, and then developed the guideline based on thinking, well, actually, maybe we can do that. Not in every case, but in a lot of cases. And it's working out where we can take a simplified approach and where we need to ask some extra questions. So the guideline, and this is sort of my view as well, is that bioprotectants represent a different situation than a conventional chemical pesticide. One, because they are substances that we know about, but because we know about them, then people have been researching them, which means there's a lot of information sitting in the research community. Now we have to look at that information, we have to evaluate that carefully to ensure that it's good quality information that we can rely on. But what you then see in a dossier as an evaluator is you'll see a lot of reasoned cases and a justification as to why a justification is not to provide a study. And that should be explained well with good quality information. And there's also the idea that some exchangeability of data is a reasonable way to go, because if you're looking at substances from a botanical substance, it's sort of saying, what's different about this, that I have to do something very, very different. And so we can think about that. That said, equivalence is a little bit more complex sometimes with microbials in particular, but also with botanicals. But in principle, when you prepare a dossier and when you evaluate a dossier, you'll see a lot of written information, a lot of reliance on the literature, and that's a good thing. And then just a little reminder I wanted to make was that for some of these substances, there may not be a separate active substance from the product, and that's to do with how they're produced. So if we take an example of a microorganism, when you put it in a fermenter, because you're trying to keep it as just a single culture of the organism you want to produce, you keep everything in nice pipe work and all contained. And you do that all the way through the system, and it actually comes out as a formulated product. So there's no way you can get an active substance out of that. That's that. And so you can't test it. So all the testing may just be the product. So you'll see a dossier where a lot of the information is just about the product. And sometimes the active substance in the product are the same material. It's sort of, you're just using the microorganism just as it is, for example. So just be aware that you might often see that. And then something else that you need to think about is when companies, when researchers are looking to develop a bioprotectant, they're often, it's not to say that botanicals or microorganisms can't cause harm, unacceptable harm, but what's happening is that companies are particularly looking for things that don't cause unacceptable harm. So they're sort of pre-selecting to remove things that are of toxicological concern. That doesn't mean to say as evaluators we don't need to check that's the case, but that's generally what's happening. Because you've got an active substance which is potentially of no toxicological concern, then the companies formulate them in materials that are also of no toxicological concern, because what they're trying to avoid is they don't want to add in co-formulants that would change that classification of their active substance. So you see often that the formulations can be very, very simple. So for example, they can be something simple like soy oil, or they can be something like a talc or a kaolin. So they're very, very simple formulations often. And that means then that your worst case scenario is your active substance and not your formulation. Something else we need to highlight is there are often no suitable or validated testing methods for these types of substances. So that's kind of where we have to scratch our heads, and that's what we need to think about when we're thinking in the human safeties. If there's no method, how do we do this? Or what methods are available that we could use recently? And just to say that there's this lovely resource that the FAO have developed, the Pesticide Registration Toolkit. It's for chemicals, but they're in the process of developing this for microbial pesticides. And in future, we'll do this for botanicals and senior chemicals as well. And this will be a great resource for applicants and for evaluators. Something that came up a lot last week and I want to touch on is a lot of questions about how do we assess efficacy, what is efficacy, and just wanted to mention that this was something we covered in some earlier series with the ASEAN Fall Armyworm Action Project. Those recordings are available and you can go and have a look at those and to understand what we mean by efficacy. So let's now get into the detail of what we're going to do. So as I mentioned before, I'm going to talk about microorganisms first, then I'll talk about botanicals and talk about senior chemicals. But before I sort of start to dive into this, I just want to ask the moderators, are there any questions that have come up that we can address now? Putra, Alison, have we got any questions?
Not yet, Dr. Gwynn.
Okay, good. Oh, that's great. I'll keep going. Okay, so what we could cover, if we look at all the data requirements, we in the last session we looked at identity and we looked at biological properties. So today we're going to move on and we're going to look at the effects on human health. When my slide moves, there we go. So a reminder about microorganisms is there's two parts to this. Is one that microorganisms can change species because you have taxonomists who look at them. We continue to understand more about microorganisms. So the species name will change, but what doesn't change is the strain. And that's the key part of microorganism, is we really need to pay attention to the strain that the applicant has put forward and that we're assessing. And yes, some parts can be extrapolated to other members of the same species, but other parts can't. And what also makes a difference is the way in which the microorganism is produced. So you've got two types of production. You've got solid state production and liquid state. Solid state is mainly for fungi, liquid state mainly for bacteria. And then depending what the producer does, you can have some producers who take all of the fermentation material. So I think I gave an example. If you're growing, say, a metarhizium on rice, your product might be the rice, and that is packaged and sold. But in other cases, somebody might take the rice, dry it down, shake off all the spores, and then formulate those spores, say, in an oil to give better shelf life, for example. And so what you end up then to assess as your active substance would be slightly different. And that the same thing happens in the liquid state. Depending, you may take everything out of the fermenter, or you may take just certain parts and say perhaps just the spores only. And what I also wanted to bring forward is some words that you'll hear me using. You'll hear me using the word MPCA and MPCP. MPCA means microbial pest control agent, and MPCP is microbial pest control product. And those terms are used to describe the active substance because the active substance may not just be spores, may contain all the other components in there. So it's a term to collectively include everything that could be in that active substance and could be called an active substance. So the other thing I said to consider is for a lot of microorganisms, we know already there's a lot about them in the research community. The literature contains a lot of information. And so for some of these microorganisms, it is possible to perhaps take a simplified approach. So what in that simplified approach, if you have a full and unequivocal identification to species with and strain, and that strain is deposited in the collection, you know what it is and you know where you can get it if you want to check it. You have a really clear description for your production process and the quality control steps that are going on there, and you're sure that there'll be an absence of the secondary compounds or potential toxins, that the active substance is formulated with inert materials, that there's actually something living in there, there's something viable, that the product actually contains something, confirmation of your physical chemical properties, confirmation it's not a human, that there's no contaminants in there. And you've got some mineral efficacy data. You could just check these points only, and if the assessment of those is good, then that's all you could do in the dossier. You could look at those minimum key pieces of data, but this would only apply to certain common microorganism species for which we already know a lot of information and which is a lot of published information. But you might see applicants coming forward with this, or it might be as an evaluator, you can look at these parts first, and if you're satisfied that these parts of the dossier have been done well, then you don't necessarily need to go on and assess all the other parts. So this is a recap of what we covered last time. So we covered the identity, and what we sort of said is you need to identify it well, and then you need to have good 5-batch analysis of what's in there, what's microorganism, that there's no contaminants in there, and to understand what it is. And this is for the MPCA, the Microbial Pest Control Active. We also had a discussion about understanding really well the biological properties of the microbial pest control agent, what it is, where it's found, what it comes from, what its host range is, what its life cycle is. And having this knowledge and this information helps us to understand where the potential risks may lay for it. So moving on to human health. Okay, so to be able to assess the risks to human health for MPCA or an MPCP that are proposed for registration, there should be data on microorganisms for their pathogenic potential. So is this microorganism pathogenic to mammals? But with microorganisms, you also have to ask the question about secondary compounds. Are secondary compounds present? And if they are, is there any toxicity that comes from those? So whenever you're working with microorganisms, you've always got a double question for every data point: is what are the pathogenic effects, what are the toxic effects? And so you have to look at both of those elements. If an applicant has made something and is able to clearly confirm that there's no secondary compounds in there, obviously you're then just looking at the pathogenic effects. So human health, right. So the first thing is acute toxicity. So these are the basic studies. This is acute oral, dermal, and tracheal or intraperitoneal for the active substance. Then for the product, you'll be assessing skin and eye irritation. Skin and eye irritation generally not need to be done for the active substance. So those the basic studies there, so that's the same approach that you take for a conventional chemical pesticide. However, the test methodology for a conventional chemical pesticide is not the right methodology for testing a microorganism. Higher tier studies for MPCA, for such as repeat dose of subchronic, are not usually necessary. I think in all the time that I have been working with microorganisms, I've never had to do that in a dossier. Because if something's going to be pathogenic, you'll find out it's pathogenic in the acute test. There's not a need to go on for the repeat dose. If you've got secondary compounds present that are toxic, then there may be occasions where you sort of say, okay, I think there's something in here that is triggering some toxicity, or there's a sign of this, and there may be a question in higher tier studies. But again, I'm not aware of a dossier where I've had to do that. Sensitization. Now, sensitization, the microbial test method for that is unreliable. There isn't a good method for testing for it, so that's generally not required at present. If you have a lot of secondary compounds in there, then you would need to do it. But if you've just got the microorganism based on the microorganism, there's generally a reasoned case and waiver for non-provision of information about sensitization. So genotoxicity data, this doesn't relate to the microorganism itself. This relates to the secondary compounds that would be present, not the secondary compounds that could be produced, but secondary compounds that are actually present in your MPCA. And the other part that needs to be provided is there should any records of any adverse effects. That's from the literature, but also from the production facility. So being aware of were there any issues from that. So I'm just going to take a little pause there. Are there any questions come through? Or clarifications on what I might have said?
Just a quick question. I mean, I think you mentioned on the production facility. So are you meaning if there was some sort of somebody in the workforce had some injury related to potential exposure?
Yeah, so one of the things you submit in a dossier is so if you're a manufacturer or a producer of any plant protection product, any pesticide, you should always keep good records of your manufacturing plant. And one of the things you put into a dossier is whether there's any adverse effects happened at the plant. Plus, it's not so much that something happened, it's then why that happened, what mitigation effect you had, and is that a sign that this substance may have toxic effects on humans. So generally it's often somebody's done something stupid, they've dropped something or whatever, but you need to look at those, because the people working the production may potentially be some of the people who have most contact with those active substances, and so that's a sort of starts to be a flag that maybe there's an issue here.
And
right, remembering, yep.
No, I was just going to say, I guess what would be interesting as well, I mean, you said that high tier studies are not normally necessary, so it would be interesting to hear from anyone that's seen those actually being used, I guess. Would be interesting as well. You said you hadn't seen one really.
That's because it's not needed. It's not because people aren't doing it or lazy or anything like that. It's because when you do the acute studies, you don't need to go to a higher study.
Yeah, no, and I was just wondering if there were any cases where they had been necessary that anyone had seen in our group. But I'm not expecting to see any, because as you're saying, it's really not needed. There is a question here. What are the mitigation effects typically put in place? Are there examples?
Oh, absolutely. So, I mean, good manufacturing practice is you look after your workers. So, if, for example, you've got dry spores and you've got somebody who's handling those, good practices, they should have suitable PPE on in the production facility, because that's just a good thing to do as an employer, that you don't want to risk exposing your staff. So, you've got good face masks of the right grade on, for example. And a lot of the safety is about your practices, about thinking about the flow of the work and how you work, and making sure that everyone's working in nice temperature conditions, that you're not creating a lot of dusts, so that you're just being careful. I mean, there's some good guidelines that FAO produce on what's sort of good practice. So hopefully all the manufacturers are following good practice. And I know in some countries, a role of the regulators is to evaluate those manufacturing plants as well. So I'm not being flippant about not having higher tier studies. So the reason mostly you're not having higher tier studies is you don't have any adverse endpoints as a result of it when you do your acute studies. So there's no need to go on to a higher level study. Okay, right, I'll move on. So thinking specifically about it. So I said at the beginning that one of the things you see with dossiers about bioprotectants is that not all the information that's in there will be provided by a study. So this table, I'm just giving sort of guidelines and trying to sort of indicate it, that some pieces means some pieces of information are required and others conditionally required. So depending on the results of one study, you might go on to do another study. And we talked about the occupational health surveillance, that really should be required, and the summary, the potential of microbial pest control agents to be hazardous, is you're thinking about what is this microorganism, where does it come from, what's its biology and ecology, and you're thinking through what it is, and based on what you know about it, where do we think the risks would lie? So, for example, we're not working with human pathogens. So we don't have an expectation that any of these things we're working with are human pathogens. That said, we're often cautious and say, well, I still want to run a study just to confirm that. And that's what 5.3.9 is saying, well, I don't believe them to be human pathogens, and I don't believe there's secondary compounds there, but I want to check it. Or, yes, there are secondary compounds in there. I've understood what those secondary compounds are, but I don't expect them to be toxic, but I want to do a study just to confirm that. Now, some reasons why you may not see any basic studies at all can be based around, for example, we talked about a microorganism being pathogenic. Now, if a microorganism won't grow at human body temperature, it can't be pathogenic to a human. So what you sometimes see is an applicant will have done some very good quality growth rate studies to find out the temperature range at which the species grows. That has to be, if they're using that as a waiver or part of a reason case for not doing acute studies, and we all want to not do acute studies because we want to minimize the animal testing we do. You might see somebody have presented to you information about the growth profile. So there's quite a few microorganisms that won't grow, say, above 28 degrees. And there's a big margin of difference between that and human body temperature. So based on that, there's no point testing for pathogenicity, because if the microorganism doesn't grow, it can't be pathogenic. Plus, you know that this is an insect pathogen, so there's no expectation it's a human pathogen. So you're starting to build up this knowledge based on what the microorganism is to say, in fact, although we say that this is a required data point and it's really important you address as well, it might be people addressing it well, not by doing a animal study, but by doing a reason case. For toxicity and pathogenicity, sorry, for toxicity, you again need to think, is the applicant telling me whether there is secondary compounds present here, and are these secondary compounds toxic? So all microorganisms produce secondary compounds, but not all those compounds have any toxicity. So it's again understanding what those compounds are, and do we expect them to be toxic? And it might be there's information in the literature that is good quality information that knows what that compound is and says, we know already it's not toxic. It's when you don't know that information that you need to do a study. And then if we look at 5.8, if we know there is secondary compounds present, and if we know those secondary compounds have a major role to play in the biological activity, and we aren't able to say what all those secondary compounds are, then you need to really think about what toxicity studies you need to them. But what you'll see in all the guidance, it says it's toxicologically relevant. It's not just finding out what's there, because that's not the question we want to know as a risk assessor. We want to find out, is there something there that will cause harm, rather than trying to find out everything that's there. So when you see a dossier coming forward for human health, what you'll often see is you'll see some studies for acute oral, dermal, and pulmonary or intraperitoneal. You may see a reason case there instead of the studies. And when they do those studies must be asking a question about pathogenicity and toxicity. But you might remember, you might also see some studies which are based on temperature growth profiles to say, I don't need to test the pathogenicity component of this, I just need to test the toxicity component. So that's for the MPCA. Then thinking about the MPCP, if the MPCA, if the active substance is formulated in material which might contribute to toxicity, then you'd need to do additional tests on the formulation. I mentioned at the beginning, one of the things that a lot of developers are doing is they're not formulating with co-formulates that have toxicity, but they're also formulating the substances which are really well known, for which is often good quality information available in parallel regulation or in good published literature, which explain that the toxicity of that co-formulant. That said, it's often you need to check the skin and the eye irritation. So you may not see another acute oral or dermal or inhalation, but you might want to think about, do I need to test skin and eye irritation? And again, this isn't following a tick spot box. It's thinking, well, why do I think there would be a risk there? Have I got sufficient information to say, okay, I'm happy with the risk that's there, and just thinking that through. So what should be coming out by now for you is that you're going to have dossiers without endpoints. And a lot of people say, but I haven't got a number to plug into a model. And the answer then is, and they say, oh, I'll make up a number. Can we come up with a number? And the answer is no. The answer is you don't need to run the models. So if you, as a result of doing your acute tox testing, you have no endpoints of concern, you don't have a need to run a model. The answer is there are no endpoints of concern. It's a full stop at that point. So again, when you see a dossier, it can look very unfamiliar because you're like, oh, well, let's stop. I haven't got a number. How do I make a decision? And that's sort of, as an evaluator, it makes it a bit harder because you haven't got that number. Think, right, when I have that value, I know I have an acceptable risk. And because you don't have that number, there's an element of having to make that judgment. That of what the risk is. But again, I sort of looked across a lot of dossiers, and again, it's not saying that microorganisms don't have the potential to be toxic, but it's saying that applicants are bringing forward substances which they've already checked they don't want to be toxic, and so that you're rarely going past providing information about the acute phase, and quite often the product part of the dossier doesn't have those acute oral, dermal and inhalation studies. They'll maybe just have the skin and eye irritation. And again, skin sensitization is not possible and not required. Part of that is to do with the testing method, but because you'll have tested it on the active as well. So when we think about operator, bystander and worker exposure, we talked already that there should be some monitoring of that. But you're not going to have the values to plug into those models. But the answer is there isn't an endpoint of concern. Now that's quite, that whole situation is very different from what you would be seeing and what you'd be doing for conventional chemical pesticides. So I'm just wondering if anyone has any questions or wants to clarify or query what I'm saying.
There's one question here, Roma, around 7.4. Are there safety data sheets available for public view, or are they country specific? The company specific, sorry. Yeah.
So the applicant should, for all the substances they have in their formulations, for their active substance and all the co-formants, they should have safety data sheets, or they must have safety data sheets. And those safety data sheets for the co-formants are usually generated by the supplier of the co-formulant. So what you'd see, if you've got 5 ingredients in there, you've got your active substance and 4 co-formants, you should see 5 safety data sheets. 4 of those would be probably produced by the supplier of the co-formulants, and 1 of them will be produced by the company who produced the active substance. So yeah, they will be available. Now, quite often those are held in confidentially because people don't reveal what their co-formants are. So that information would sit in the confidential part of the dossier, but you would have a safety data sheet for the overall product that you've now produced. So there's individual safety data sheets for the individual components are held confidentially, but a safety data sheet for the formulation is publicly available. It must be publicly available because you have to supply it with the product when you supply the product.
Yeah, excellent. Okay, thanks.
Okay. So what hopefully I'm giving you a picture of is that when you as an evaluator, when you open a dossier for with a microorganism and you look at your human safety part, it's going to look very different to the conventional chemical pesticide if that's what you've been working with before. So I mentioned then, how do you test? So many of the methods that we use using to prepare a dossier as an applicant are methods that have been developed for conventional chemical pesticides. Now you come along with a microorganism and those methods really don't work. The fundamental principle of what a conventional chemical pesticide does, and that one molecule of this substance elicits one response, that is clearly not true for microorganisms. You have things like the threshold by which you get a response for microorganism, etc., are very, very different. So back in 1998, in fact, the US EPA developed some specific guidelines for testing microorganisms, and I've put the link here where you can find these methods. They're called the Series 885 Microbial Pest Test Guidelines, and they develop certain guidelines for different parts of the dossier. So I've pulled out here just these are the guidelines that are TOX test guidelines. So when you get that dossier, you will see that the applicants have used these test guidelines, or they've done it well. And if they haven't, they should have used these test guidelines, because if you use a chemical test guideline, it's not going to test your microorganism well. So you should be using these as the best guideline. Now, there's a lot of conversation about saying we need to update these, we need to improve them, we need to think about them, and that process may happen. But meantime, you should be working these. So evaluators shouldn't be asking for using the chemical guidelines, but they should be using the microbial pesticide test guidelines. And I say globally, these are really the only good ones available, and these are the ones that everybody uses. They're freely available on those links. You can download them, and the testing labs should know about them. So as an applicant, when you want to run these tests, what's really important is working with test facilities that are used to working for microorganisms. So I know there's lots of testing facilities say, oh, I know what I'm doing. And it becomes very clear quite quickly that they don't. So one of the things that you need to think about when you're contracting this work and when you're doing the work, that it's with a test organization that knows how to run these guidelines, and that they have good experience of working with microorganisms, because if they can't handle the microorganisms, they don't run the tests properly, and you're not getting good quality results from it. I've seen a flood of questions come in, Alison.
Actually, I've just posted exactly that link in the chat for everyone. There was one here from Vietnam, I think, regarding the SDs. Is there any specific format, or is the EU fine, the CLP classification? Okay,
that is down to a country decision. So as to what they consider an acceptable format for their SDS sheets. The US system is slightly different from the EU system, just in terms of format, etc. So that the format it takes, you need to speak with your regional regulator to find out which is their preferred format and language for those SDS sheets. So that's something that you should talk about, and that's something I really would encourage, is that there's always really good dialogue between the applicant and the evaluator, and not the dialogue at the point where you've prepared your dossier, right at the beginning when you wanted to prepare the dossier. So you can ask them questions like that, because for the evaluator it can be quite frustrating. They've got all this paperwork which sort of says, oh, it's just in the wrong format, or it's the wrong language, and I can't do an evaluation. So it's always really good to talk to the regulatory agency, have a good conversation about what data you're going to provide, what methods that you're going to use to provide that, and what format that you're presenting it. So then it's not so frustrating as the applicant, who then gets the dossier back and say, look, it's not prepared in the right way. So it's really encourage everybody to talk together.
Great point.
So good. So, and you can see this. So there's a method for so the lovely background document which just sets the frame for what's happening with these studies. And then there's an acute oral toxicity, pathogenicity test guideline. There's one for dermal and one for pulmonary, and injection. Injection's often not used now because to some extent, if you inject, not for the microorganism, it might be the toxin, because if you inject a microorganism, you really do expect the animal to respond, regardless of what microorganisms you put in them, because they're just not going to like having microorganisms put in them. But it doesn't tell you anything about your particular strain, etc. So often that's a study that's not done unless it's done for toxicity. And because you can sort of get false results or false positives with that result. But I was saying it's really important that the testing lab knows what they're doing, because they haven't just got to dose the animals correctly, but they need to be able to recognize if there's any pathogenicity signs at the end of the study in that organism and that animal. So they need to be able to recognize that the microorganism has caused pathogenicity. Something that you see in these study guidelines is sometimes, so what they might have tested is that you test the MPCA or MPCP, whatever you're testing, as a whole. But sometimes what you'd have is you autoclave and kill the microorganism, so that you can then tell the difference between the effect you got when you had the microorganism and the potentially secondary compounds. And then if you killed the microorganism, the effect you're seeing should really just then be the effect from the toxins. That said, like working with microorganisms, it's sometimes not quite as clear as that, but that's broadly the idea why you'd be testing an autoclave sample as well as a sample with viable microorganisms. So just in detail, this is sort of what the opening page of the guidelines look, and I put that there because it's just to sort of say, just you should see the reference to these documents, you should see these numbers, you should see these words in the study report that has been used by the testing laboratory. So you're looking out for these guidelines. So that's sort of where I was going to get to, talking about acute or about mammalian safety testing. And I just want to pause and just say, is there any sort of questions we can gather together? Any sort of, and as Alison said, there's no stupid questions, because this is really unfamiliar territory often, and it's also, it's not sort of black and white, so it's quite complicated. So Alison, have there any sort of particular questions come through related to this part?
Not at the moment, but what I've actually asked people specifically is that for regulators in the room, we're kind of keen to hear, in your experience, are applicants coming to talk to you early in the process at the start as they prepare their dossier, or later as they submit it? So I'm keen to hear your feedback. And also, yes, from the other perspective, I guess for any potential applicants, are you talking early with regulators, or are you starting to talk to them when you submit it? So it's just asking that question that Roma was really sort of pointing at, around getting early discussion and dialogue happening. Be interesting to see what your experience is. So please share. We're not recording anyone's name or anything like that. So it'll be just nice to sort of see if you have some experience in that.
Yeah, and I'd really be interested to know if evaluators have been getting sort of microbial dossiers where they haven't been using microbial pesticide test guidelines, and sort of saying, you know, what kind of problems does that cause for you if they're not using these microbial guidelines? So just thinking about the results that you get then from these studies, what you'll get is not so much a number. Sometimes you get a number, sometimes you don't. But sometimes what you're getting is there was just no effects. So the conclusion of the study was there were no effects recorded, there was no pathogenicity, and there was no toxicity. So there's no effects recorded. So you don't get a number, you just get a statement that there was no effect. So that's why I'm saying you can't put it into a model. So really interesting to get some feedback as to whether evaluators have been getting dossiers where the applicant hasn't used these test guidelines.
Okay. Just, Robin, there is a question here from Mohammed. What's your point of view about sharing data between notifiers?
You know, I think that's such a good thing, especially when you're thinking about animal, that they're doing tests on animals. This is, if nothing else, I think the, so for notifiers, okay. So I was thinking about evaluators. Yeah, for notifiers, this data, it costs a lot of money to do these studies. So and I've said before that the microorganism, it's not just a species, it's a strain, and how it's produced makes your active substance. So when you run a study with that material might be very different for somebody else's production process. They might have different quality parameters, they might have different standards that they're working to. So to extrapolate the animal testing between different notifiers is difficult with microorganisms. So generally, I'm saying you're going to have to generate your own study again. Now, if you've done thinking about equivalence, that equivalence is really hard with microorganisms, because you've got to have got the same species, the same strain, and the same production method, but production methods are confidential. So as a notifier, how do you know you have the same production method? How do you know you kept to the same standard? So you can't. And I think as an evaluator, the evaluator would think in that way, and also sort of say, I don't know that you did things in the same way, therefore I do want you to give me your results with your MPCA. So I really know that that is correct. So I don't think it can necessarily have extrapolation with notifiers, or that's a very hard thing to do. But I do think you can have shared information that if you go to another country, that these studies aren't redone again. You know, if somebody's done this in the USA, Europe, Brazil, or Australia, New Zealand, or somewhere like that, and is bringing the study forward, providing you're able to look at it and say, did they follow the right guideline? Is the methodology well carried out? Do they give me the raw data so I can double check that? And have they come to the right conclusions? If you can satisfy yourself on those points, there's absolutely no need to redo a study, because we're trying to prevent unnecessary animal testing.
Excellent. Thanks, Roma.
So that's where, as much as I'm going to say about sort of the sort of animal safety testing, and it probably you're starting to realise that when you get a dossier, it's going to be a lot smaller for this. And it's just as a general sort of rule. If we imagine, when I prepare a dossier and I pile all my paper up, I've probably got paper sitting maybe a metre high. Now, if you do that for conventional chemical pesticides, you've probably got 20 stacks of metre high paper. And some of the difference is because applicants are not putting forward substances that will trigger tox, which trigger the need for higher tier testing, which trigger these extra studies. So it's a much smaller study. You do the acute test, you have no endpoints of concern, you can stop them in the study. And one of the areas where you see sort of information not available is in residues. So the general principle for microorganism is that it should be possible to prepare a rationale for a waiver of data as to why the MPCA is not hazardous to mammals. So that will be based on the biology and ecology of the microorganism. And that's why we were talking in our last session, why it's so important to have good information about the biology and ecology, because you can use that to explain that you don't need to do residue studies. The other part of that is how much do you apply relative to background levels? And if you're applying a similar amount as already found at the background level, humans already have exposure to that, so you're not adding additional exposure or an additional risk. Now, if you've got secondary compounds present in your active substance, you just have to think what happens with them. So but it may mean you don't need to do a study, a residue study, but what you think is maybe the applicant's done a degradation study to say, well, look, I do have secondary compounds in there. They're not toxicologically relevant because when I did my acute study, I had no endpoints of concern, or I did have an endpoint of concern, but I know it degrades really rapidly. So a residue is a result of exposure and toxicity. So if either of those are absent, you can't have a residue. Then thinking about people say, okay, but if I'm applying a microorganism and it grows in the, in the wound of the plant, or it sort of colonizes a leaf, or it's a hyperparasite and it attacks the fungi, it's grown a bit, and then it could be producing secondary compounds in situ. That's absolutely true. That could be happening. But if you ever do a calculation for how much is produced, it's a tiny, tiny amount. But what you should have is the applicant should be bringing forward to you that calculation and just sort of saying and confirming that it is a small amount. As I said, if the secondary compound is of toxicological concern and they're involved in the mode of action, then you do need more information about this. So again, saying, have you got toxicity? Have you got exposure for the secondary compounds? But the majority of the time for microorganisms, for residue testings, you will have a sort of 1, 2, 3 page of reasoned case as to why the microorganism isn't going to have residues and why it won't be concerned. So the fact that microorganism is still alive on the leaf is okay, because it's not a human pathogen. So it doesn't matter, it's still alive. And if it's alive at a level which is every time we eat a lettuce or we eat a cabbage, it's on there anyway, you're not giving any additional exposure. So more or less residues is a reason case. So the OECD guidance that I've indicated, it has some really nice explanation of this, and sort of, in fact, the title of this section is reason case for non-provision of data for residues. So again, it would be very uncommon to have anything but a reason case for the residue section of the dossier, and that takes out a lot of work from the dossier as well, which it takes a lot of work for the applicant and the evaluator, but it doesn't mean that you don't present really good quality work for this part. So yeah, okay, so that's for residues. That's really quite different to what somebody might be used to for a conventional chemical pesticide. So again, I'm going to ask the question, does that make sense to people? Have you got any questions or clarifications about what this part of the dossier would look like?
We haven't got any questions, but if people can put in their reactions, maybe a thumbs up if that makes sense. We would be also quite encouraging of that too. So if you go to the reactions button, which I think all of you should have, you may not have it on your phone, feel free to give a thumbs up if that makes sense. Oh, there we go. You're getting quite a few on the side there.
Oh, good.
It's quite
Excellent.
cool too.
Yeah.
I quite like that.
I like those. Yeah, that's really great. If you can keep doing that, I really like to see that, because then I know that I've said something that makes sense to you all. So that's really lovely, and it looks nice, because I can't see you, so I know that you're all still there. It's lovely. Okay, so that was what I was going to do about microorganisms. Now I'm going to go and think about botanicals. So microorganisms are way simpler than botanicals. So it's going to get a little bit more complicated now. So just as a little bit of a thought. So again, with botanicals, we talked about identity and physical chemical properties last time. We talked about that, you need to think about what was the species that was used to produce the botanical substance. How was it produced? How was it grown? How was it handled? How was it manufactured? How was it processed? And we sort of say all of these aspects need to be really well described in the dossier. And the reason they need to be really well described is so that you can understand where the risks lie for human health, but also for the environment and non-target organisms, which we'll talk about next time. So it's really important that those foundation parts of the dossier are really well done and really good quality information. So just a reminder about botanical, these are plants which have been the source of different types of substance. So there's a garlic extract that's used against nematodes. We've got thyme, which produces thymol, which is used as an insecticide and as a fungicide. The Simplicon, it produces tea tree. Clove oil has also been registered as an insecticide. Orange oil is both an insecticide and a fungicide. And of course, we all know neem, a really well-known botanical source. So when we think about botanicals and just sort of unrolling, think, where do botanicals come from? Well, all plants produce these secondary plant compounds because they're trying to stop things eating them. They're trying to stop the insects eating them, and they're trying to stop the diseases attacking them. So they produce these naturally, they're protectants. Some of those we exploit in foods, think of all the herbs that we have because they've got these lovely aromatic flavors and tastes. But these substances, because they're in plants to protect the plants, no surprises, they're quite interesting if you can extract them, and then you can use them for plant protection products. But when we're talking about botanicals, like for microorganisms, I use the term micro pest control agents. So for botanicals, I'm using the term botanical active substance. It's different from a chemical active substance. And why is it different? That's because it's not going to be a single molecule. Every likelihood, it's going to be a complex of different molecules in different quantities. And this is why it makes botanicals a little bit more complex. And so the EU originally developed a guidance document. The OECD picked up on that guidance document, and FAO picked up on that guidance document, because it's just a system to say, well, how do I handle these really complicated substances? How do I do the testing? How do I adapt all the methodologies? How do I do that? So have a look at that particular guidance, or have a look at the FAO guidance, which distills that down. So they're a really heterogeneous group of substances. So you could get an active substance which has got 100 different molecules in it, or you could get an active substance which has got 2 in it. Both of those can happen. And the components in there may or may not be biological or active, or they may or may not be toxic. So what you're trying to assess is which of those is true and to what extent. So before you get to the point of thinking about any testing, what you'd be looking at as an evaluator is looking at what's the quality of the source material, how well was it identified, how well is it cultivated. So for example, if somebody cuts the plants and leaves them lying in the field and they get microorganisms growing all over them, you start to think, actually, they could have sort of metabolites from the microorganisms in there. So it needs to be good quality processing parts. So a lot of people will dry the plant material down, which stops anything growing on it. You need to really know the manufacturing process and then look at how the active substance is defined and what's in there. And as an evaluator for human safety, you actually need to look at that part of the dossier so that you can understand all of that and identify where the risks would sit for this substance is. So we talked last time about how you should identify that technical grade, that botanical active substance, and that you need to profile it. And it may be, it's a big mixture, but what you're looking for is every time you produce that botanical, it's the same mixture. It looks exactly the same. And that's the principle that you've got that fingerprint. And then what you as an evaluator is saying, okay, I've looked at all that information. Where do I think the risks sit for this type of substance? What evidence has the applicant given me for this? So is it all a known specification? Is this something I can find about? So like neem, there's a lot of published information about neem. So there's a lot known out there, and there's a lot of knowledge about where the risks might sit. And if somebody's using, like oilseed rape oils used, we know it's a food ingredient. So if it's produced to a good quality, like food grade, I'd probably have a different approach to the risks that it represents to something that isn't food grade. But then you're going to have some substances where somebody's found this great new plant and they've extracted the botanical, and you've got this lovely fingerprint and sort of saying, well, okay, I'm going to do some animal testings to see if I get any endpoints of concern. Now, of course, if you get no endpoints of concern, you don't have any toxicity, then it's the same situation with microorganisms. The conclusion is no endpoints of concern. And again, it's not the plants don't produce substances of concern, it's that companies are not developing things which have those components of concern. But as an evaluator, you need in front of you the data and the evidence to be happy about that. Then you'll have a group which it's never been researched before. There's absolutely nothing known about it, and you're thinking, okay, we need to do a lot more information here to really understand what's going on. And the other part is, if somebody's identified the component of concern, it may be also that the applicant has changed their manufacturing to remove that component of concern. So again, you need to look at what they've done, how they've produced the botanical active substance, to say what are the risks, what I'm concerned about. So I think we used this example last time. This is from black cardamom. So this is not untypical for a sort of profile that you would have for botanical active substance. And what the applicant would have tested this entire mixture, and they were in the studies and sort of saying, okay, what's the results I get from that? But sometimes what you have is you have one big peak and lots of little peaks. And then the applicants will say, I quality control around that large peak, the other peaks sort of bubble along. And so then the arguments they put forward in the dossier are based around that component of concern. So that's where we were before, and I was just going to move on to human health. Were there some questions that people wanted to pick up on that before I go into the details of think, how do we test this funny mixture of substances?
No. Oh, wait a minute. There may be a question here. Actives extracted from biologicals, but involves further manufacturing, including mixing with chemical adjuvants. Will it still fit into the biological definition?
Botanical, but no. That's what you shouldn't be doing. So I'm talking about botanical active substance which just come from the material. The moment you put other substances in, exactly the same rules as chemistry, chemicals start to apply. But if you're adding components that do other things in there, you need to test that. So if you've got your botanical active substance as your active substance, you'd need to test that. And then if you put other things in, you need to test that for your product as well. So absolutely, of course, you have to test it. And yep. Yeah,
it's good. So, good to have a definite answer.
We just don't
want to be.
If you do that, you have to test. Yeah, completely.
And here's another question from Cyril. We tried neem, balsamina, and turmeric leachates to control fungal diseases in mango fruit as dipping methods. It seems effective. Is it advisable to know the residue levels on it? Some of my seniors recommended it for further validation.
Right. Yeah. Okay. So that's kind of an interesting one because, and I'll come up to residues later. But before I answer that, I'll leave you to think about it. Thinking, what if you've taken something from a plant, and these are compounds that are commonly found in plants? What would your residue be? So think about that, and we'll, after I've talked about human safety, we'll come back and answer that.
Great. Thanks, Roma.
Okay. It's a good question, and I'm going to directly answer that later. So, botanicals, because something comes from a plant, we can't assume that it's not toxic. All of us know too many examples where botanicals are great at producing some substances that are toxic. Again, applicants or companies are usually trying to bring forward something into the market which isn't toxic, but that doesn't mean to say it won't be toxic. So therefore, as an evaluator, you need to be able to have in front of you sufficient evidence for you to judge whether something is or is not toxic. But that said, there are some botanicals which are really well known, for which there's lots of information in the literature. And if you can find reports which says with this specification, with this peaks, with this composition, I've seen a paper that's sort of work already done, which shows in the public domain now, remember this can't be confidential, that's in the public domain with the same composition of the active substance. And so it's quite reasonable to use that to avoid unnecessary animal testing. But you have to be able to match up your specification to the specification that was tested in that work. That's a really important part, because if there's other components in there, they're not testing like with like, you've got testing something that's different. But if you know that a botanical active substance has a component of concern, the literature tells you what that component is, then it's quite reasonable to sort of say, okay, I can look at other information about that component of concern. And so often you'll find, so for example, because it's botanical active substance, there's quite often quite a lot of information in things like codex, or thinking about adult daily intake values. And sort of, so what you're looking at is the amount that this is in this active substance below adult daily intake values, is it acceptable? So the applicant should be putting forward information from other parallel good quality regulatory work that they can use to avoid doing unnecessary animal testing. But there is a point at which you think, actually, none of that works, we need to do animal testing. But I really encourage to look and say, is there information already available that I can use? And one of the things you can do is thinking about the use of QSARs and modelling what we think could happen. And that's when you sort of, there's available data presented showing that similar exposure to known levels of the botanical active substance by the same route for many years hasn't caused an adverse effect, and that then this information can be used in the dossier instead of generating new studies. So just me repeating there, sort of saying, look across at other information that's available. Don't just jump in and do new studies. And again, this is where the applicant should really be talking to the regulator and going in and say, look, this is my composition. I've got all this evidence for the literature. Are you happy that I present this information and that this is sufficient information? Now, of course, the evaluator, until they've got the full dossier, they can't make an unequivocal decision, but they can help you and guide you as to what you should do and make sure that unnecessary studies are not being done. So, so the idea being, if there may be sufficient scientific justification to confirm no unacceptable risk, but if there's not, you need to go on studies, and these need to be in the dossier and they need to be assessed. So the studies and the methodology follows for botanicals are actually the same studies as used for single conventional chemicals. That makes it a little bit complicated because sometimes these substances are quite complex substances. One of the more common things you see is a lot of botanical active substances are highly volatile, and so they volatilize really, really quickly. And then you need to be working with a testing lab, need to be handling materials very carefully so that you've actually delivered to the animal, to the test arena, the active substance. It hasn't all volatilized away. So for example, you need to think about the quality of the plastics. If it's in plastic, you need to think about the quality of the lids, so that the sample that's tested is a good quality sample. And the other thing you have to think about is that these samples, you need to be careful that they don't degrade and that they don't break down, so that what's getting to the testing labs and not the testing labs using are good quality active substances. Because remember, you might not have the same stability you would have with a conventional chemical pesticide. You've got highly volatile substances, so as soon as you open the lid of the test container, it's volatilizing. And most of the study guidelines have got extra pieces of information to what to do if something's highly volatile. So just saying to applicants to look for that and as evaluators, just to think, was this a good quality study? Was it done well? Did they adapt the protocol in the right way for something that would be highly volatile? So just thinking about the toxicity of the technical material or the formulated product, what you're doing as an applicant and as an evaluator is to ensure that there is sufficient documented knowledge. If there's sufficient documented knowledge available, that you can use that to stop doing unnecessary animal testing. It's saying, but you've got to check that the information in the literature is for a substance that was tested that is the same specification of what you're testing, and that you can do read across. And particularly if you know that most of the botanicals are okay, but there can be a component of concern, is the level of that component of concern the same in the studies in the literature and not? And again, remembering you can't use confidential data, you've got to use public domain data. There may be other regulatory frameworks which have reference values that you can use, again, to save you doing animal testing. So if something's been looked at and assessed as part of thinking about adult daily intake values, the documents that they use to come to that decision, have a look at those documents, and can those documents be equally applicable to the dossier that you're preparing and bringing forwards now. And it's only when the adverse effects are not sufficiently characterised would you move to animal testing. So it shouldn't be, oh, I'll just run the animal test. You need to be really thoughtful about whether you need to do them. And just thinking about, is it reasonable to suspect there may be a concern of some studies, and you must, as an applicant, you need to provide the information to allow the evaluator to make those decisions, to understand that. So be really clear about how you put that information across, especially if there's a lot of dialogue. Thinking about components of concern. Sorry.
No, I was just thinking, and there's a couple of questions here, and one was, how do you define botanical toxicity? And you sort of touching upon that now. So I thought that might be good just to throw in there. And the other question, not quite sure what this means, but does substances extracted from other than botanicals do you apply the same protocols or regulations?
I don't think we can answer that and make that extrapolation, because it depends on what the substance is. So what I'm saying about botanicals is we already have good regulation for conventional chemical pesticides. What I'm talking about today is saying, okay, for these botanicals, where there's something different, what are the adaptations that I need to make? So if you've got something extracted from something else, you should be able to follow the conventional chemical pesticide rules. That said, I am aware that those most of the development of that data is based on the principle of a single molecule chemistry, and if you've got mixtures, it's a little bit harder, and you would have to make adaptations. And maybe some of those adaptations are similar to what the adaptations you make for botanicals, but they might not be. So again, I think you'd have to talk to your regulator and just think that through. But the basis of all of this is really understanding what's the composition of my active substance that I want to test, and where are the risks associated with active substance. So thinking about the first question was sort of saying about toxicity for botanicals, is not all botanicals are toxic. Not all of them are non-toxic. So that's what we're going to try. So that's why if you can't find the information in the literature, if you can't find good quality information, then there's a point at which you think we do have to do some study. But before you do the studies, one of the things you can think about is, so I've done my fingerprint profile, and I can see one peak there, and it's a substance that I think could be a component of concern. I'm not sure, but it could be. So what can you do? And this could be where thinking about the principle of threshold of toxicological concern. Now I'll put the the reference to the guidance document. It's quite a nice guidance document that sort of talks about this concept. And the basic concept is it's to help to qualitatively assess the risk that's of a substance. So it's thinking about it, sort of saying, well, actually, maybe we can't even test this. So how do we go about it? So have a look at the detail of that approach of threshold toxicological concern. And again, say, can I apply the principles of that? So if a component of concern has been identified and toxicological data, in addition to technical grade, are deemed necessary, then you have to think about the hazard identification, then should focus on specific components. If components of concern have not been identified, then you don't need to do that. You just need to have good identification and characterization. So what, again, I'm trying to sort of convey forward, and probably a little bit heavy-handed, sorry if I am, is just as saying it's not about testing everything and finding out everything we can know. It's about thinking this through and thinking, where do I have something that I'm concerned about? Where do I have a risk? And then just testing and making sure that the testing that you do correctly assesses that risk. So not all botanicals will have a component of concern somewhere. Like I said, olive oil, oilseed rape, if it's food grade, unlikely to have a component of concern. But if someone's found a new plant, then you might have a component of concern. And you need to, as an applicant, think that through. And also think, can I take it out of there? Just remember that.
Yep.
Okay. So then getting on to residues, and this relates to a question that was asked. So before I go into detail, are there any other questions come up about sort of the human testing components of concern? Because botanicals are horribly complicated.
No, but there's an interesting question here, and we're talking about botanical substances. How about substances obtained from the oceans and shoals, from plants, and particularly from marine animals, whose body parts may contain substances of some level of toxicity or application for use?
Yeah. So, so this is down to each country as to whether they have an approach for botanicals that's accepted, etc. But if sort of an innovator came to me with that, what would I be thinking? So I would sort of say, okay, you found something. What do we know about it already? What's published in the domain, the literature? What do we know about it? And if the answer to that is nothing, then I can flick back. If the answer is nothing, within this group 3 system, well, we don't know what it is, we don't know the concerns, and then you do have to test, because you need to say, well, this is completely new, we don't know anything about it, so we really need to test what we've got. So just because you've got to prove that it doesn't have toxicity. Yep.
But I think, so what you're saying is that it applies to both, if it's obtained from a plant or particularly from a marine animal, in this case, you still have to go through that process of actually understanding what's in there. Yeah.
Yeah, absolutely. Absolutely. We can't assume something's safe, but we can't assume it's not safe either. So it's kind of like trying to work our way through logically as good scientists and as good technical people to say, okay, where do I think the problems may be with this substance? So this is where these dossiers are often really different, is because every data point you have to be really thoughtful about it and really think, what I've got, what do I need to do? So residues is a good example of that. So a lot of botanical substances are already in plants, and we kind of eat them all the time. So some of the information, when you're thinking about residues, that an applicant would be bringing forward is that evidence and saying, how much do humans eat of this all the time, and how much do I put out when I apply this as a plant protection product? What is the person going to be eating? And how much are they already eating all the time? Because this is a substance that's always found in plants. So that's your first sort of argument. So saying, actually, I'm not adding anything. They're already exposed to this. Then the other part to think about is, if I do have something of toxicological concern, how do I identify it? How do I find it? How do I track it? So one of the things you want to think about is thinking, actually, does it degrade? Does it degrade so quickly that it won't be of concern for that reason? So, if you spray it and by the time it's harvested, it's disappeared, it's not an issue. So again, thinking about that. Now, doing that on plant might be quite difficult, because how do you detect something that's already in the plant already? So you've got to think quite carefully about the methods that you would use to say how does it degrade and how quickly does it degrade. And there may be good information in the literature on this, or you could apply some good models like efficacy models or other models there are for chemistry, to just think about what's going to happen to these molecules. Where do they go? It's not entirely true, but broadly you can say it's very rare for something to break down and to be more toxic than the original with these botanical active substances. That's not to say it won't happen, but you could sort of think about that and thinking, can I find the evidence to say that that is a reasonable approach to also take? So then if it's necessary and technically feasible to synthesize the component, you could radiolabel it. What I know from experience is it's often not necessary and often technically not feasible to synthesize the compound. It can be, or you can do it, but it costs a lot of money, takes a long time, and does it make it safer? So that's why I'm saying to applicants and evaluators, think about, how quickly it breaks down, how quickly it degrades, what does it degrade into? Is it degrading into things that toxicological concern? Is it at a level that it would be a toxicological concern? And work through all of those approaches, because it's really hard to devise testing for residues for botanical substances. And as I sort of mentioned, that a lot of the time these botanicals may already be in food and feed, and we can think about, okay, what's existing exposure levels? Am I increasing exposure or not? So that's kind of where I was going to get up to for botanicals, and for human health and for residues. And I want to pause to see if there are questions, because I know botanicals are deeply confusing and a very, very broad group of substances.
Yes, Dr.
Oh, go.
Oh yeah, yeah, Dr. Gwynn, I do have a question. So from what you have explained, I get a sense that knowing what you're working with is kind of the starting point of everything. But it looks like plants have a lot of things going on, like a lot of compounds. Is there like a database that explains a lot about these compounds? And there's also a question in the chat asking about these database.
Yeah, I think so. I'm not aware of the database that they're talking about specifically, but I think it's great that there's databases, it's great there's public information out there. But what you have to be careful of and just check is, for my particular botanical active substance or for the botanical active substance that's been put forward, does that specification match up with what's in the literature? So it might match up for one component and address it, but does it match up for the other components? So you maybe get part of an answer. And I think this is the difficult about botanical active substances. The plant source, how it's grown, how it's handled, how it's processed, means that you can have two plant sources, and they could be very different. Now, neem is very different. Neem is so well researched. There's a lot of information. There's a lot of public domain information about profiles, about the, whether it's azadirachtin A or D and the compounds. And if you do a really good characterization of the active substance, you'd be able to then lean on sort of literature that's out there.
Yeah, thanks, Dr. Gwynn.
Yeah, good question.
Back to you.
Okay, so Alison, was there anything else?
No, that's really good at the moment. Thank you.
Okay, great, good. So let's see. Thinking about a little bit of feedback now about what I've said about botanicals. Can you give the reactions? Is this making sense, or am I sort of skimming over things? Am I leaving you with more questions than answers? Are we doing okay? All right. You can put your thumb down if I've missed some. Okay, right. I like the positive feedback. Thank you. But don't hesitate to ask questions if I haven't made anything clear.
There's one question here, Roma. Do all botanical products have the same pre-harvesting time?
No, you see, that's what's different. So some people may harvest it and dry it down and get it into extraction straight away. Some people, if they're doing really well and they're buying plant material, or they've got growing all over different parts of the country, they'll be getting that all coming into their main manufacturing part. They're sort of drying it down. So you've got the way in which it's grown, the land it's on coming in. You've got the plants coming to a central facility, then you generally process it somewhere, you mash it up somewhere, So yeah, they're all very different ages, and that's what makes botanicals hard, is because they're going to be mixtures. And I mentioned it last time, but I'm going to mention again, is also remembering that you need to check the land that the plants are grown on. So for example, if somebody's growing the plants and spraying pesticides, you're going to have to test your botanical active substance to make sure there's no pesticides still in there.
Yep.
But it's really important to do that, or if it's grown on contaminated land, but there's no lead in there. So when you do that profile on that component, you need to, if you can't be certain that the land on which these were grown was free of pesticides or free of potential impurities, you need to test for that as part of your assessment of your active substance.
Yep, great point.
Okay, so everyone's happy. I'll move on. Great. So semiochemical dossier data requirements. So, you know, when we think about semiochemicals, this seems much simpler because, yeah, they're sort of complex compounds of semiochemicals, but they're chemicals, you know? Not quite. So again, when we talked about semiochemicals, I talked about the identity and specification last time, physical chemical properties. I'm going to go on to talk about human health today. So what are pheromones, semiochemicals? So these are compounds produced by one organism to evoke a response in another organism. They could be something like a pheromone, which is a food attractant. Some of the best known ones are what are called straight chain lepidopteran pheromones. So these are the substances produced by lepidopterans, by moths, and often they're mating substances, so that the females emit these substances and the males try to find them. And the way in which some of the products can work is that you produce so much female pheromone, the males can't find the females. They can't mate, and you don't get next generation. But there's other ways of using semiochemicals. So mating disruption, which I've just described. There's lure and kill, where you're bringing you're attracting the population and you kill them with an insecticide. Then there's mass trapping, which is where you're just, and it's often food pheromones are used for this, where you're attracting the insects in to a food, and then they get caught in a trap and they drown or something like that. And the level of sophistication of how these substances are used is quite variable. But generally, when these substances are used to monitor, they don't need to be registered. They only need to be registered when they are being used to control the population. So why did WHO and FAO decide to include them in as bioprotectants in the same guideline? And that's because what we have to think about is they don't have a toxic mode of action. So they're not killing something, they're just changing the behavior of something else. So you don't have that direct toxic effect on them. They're very, very target specific. So it has to be exactly the right combination of compounds to elicit a response. Any other combination just doesn't work. So they're very, very tight. And then they'll often only have an effect against one species and nothing else. If we think about something like mating disruption, you went into an orchard that's got, or you go into a cabbage field which has got lots of things like Plutella in it, etc., diamondback moths. These moths are communicating with each other all the time. They're producing pheromones all the time. We just can't sense them, but they're out there. So one of the things about semiochemicals is there's already existing exposure of humans to them at background levels. What you then need to work out is what is the background level, and is the amount that I'm putting out similar to what's already been exposed to, so I don't have an additional exposure, so there's not an additional risk. These substances are used at very, very low rates. We're talking of milligrams per hectare, kind of, right? They're highly volatile. They dissipate very rapidly, and they degrade very rapidly because they're designed to do that. The insects don't want to, they want to sort of say, I'm a female here, I'm looking for someone to mate with me. But if there's too much of it, the males can't find them. So that the substances are designed to break down very rapidly. And they pose a very, very low risk to human health. Mostly they have no residues. Also, when some are sprayed onto plants, which is a newer sort of approach, you have to think about residues. And then the other thing that's hard to work with is anything you're doing is on a landscape scale. So because of all these reasons, there's special provisions for them that they're slightly different from conventional chemical pesticides. So what you then have to do is that the data requirements need to be adapted. So mostly the applicant will be following the chemical data requirements, but they'll be adapted, and there'll be a lot of reason cases as to why certain pieces of data do not need to be provided. You should never say not applicable, not needed. You have to explain why something's not needed, and that explanation should be based on the technical features of the substance you're working with. So in terms of thinking about human health and toxicity of the technical material formulated, in general, you need the information about exactly what the senior chemical is and how it's going to be used, because this may be sufficient information to say there's no need to do animal testing. So just to think about that. And then think about the route of exposure. So how is this substance applied? Is it applied in a retrievable dispenser? So often senior chemicals are absorbed onto plastic, and those plastic containers are put around a field, and then those plastic containers are brought back again. So the edible part of the plant isn't being sprayed. It's actually not getting a dose of the senior chemical. So you need to think about how it's been used. So it's unusual sort of for human health that you're having to think about what the substance is, what's known about it, but also sort of thinking about how it's going to be used and what exposure there would be to humans. So if from those approaches you can't exclude that there's no exposure, and then you're going to have to think about doing some studies, and that's where you would be thinking about doing some acute oral studies. But what I would strongly advise is to, and these studies were the same studies as for a chemical. Again, you've got something that's highly volatile. It's really hard to work from these studies. Guidelines have what to do with volatiles. But before you get to the needing to do studies, it's a question of saying, do I actually need to do the studies? Is there exposure in a way that requires me to do the studies? And an applicant should be able to, depending on how a senior chemical is going to be used, should be able to provide a reason case for not producing these studies. So you may see dossiers where these studies aren't there, but you should see really good evidence as to why the studies aren't there, and that you can use to say, yeah, no, I agree with this, that these studies aren't needed. So again, as an evaluator, don't always expect that you'll have the studies there, but you should have good information to explain why the studies aren't there.
Roma, in your experience,
Yep.
is that happening a lot? Are evaluators happy with that in your experience?
Yeah, it's a mixture. So evaluators who have worked with senior chemicals for a little while, yes, they're happy with that. But what you sometimes see is, well, applicants and evaluators who are less familiar have gone ahead and done the test. And I'm sort of looking and thinking, why did you do the test? Because what does that test tell us to help us make a risk assessment? And sometimes they're not giving you any information that you couldn't have found anyway, and going, well, you know, you've got no exposure, so you can't have a risk, you know, that kind of approach. So the same applies for the residues. This is, again, thinking about you're most likely to have a reasoned case for residues, because remember, you're putting something out to change the behavior of another organism, another insect. You're not, and a lot of these things aren't sprayed onto the plant, so there isn't a residue there. So you'll see mostly you're going to see reason cases for residues. If it's not possible, so if somebody's using a sprayable pheromone, then you need to start to think about two parts. There's one, what would be left on the plants in terms of toxicity, and is it degraded? So these substances are often highly volatile. Is it degraded so that there's no human exposure? And of course, if people are looking at slow release formulations, that changes, and you need to then think about, okay, is it still on the part of the plant that somebody's going to eat? And then if you don't have enough information to answer that, then you need to do some study.
All right. And a silly question here. I mean, you're looking at maybe the impact on human safety, human health. And you said before, I mean, obviously, often these are very specific pheromones for a specific insect, but do you have to prove that it is just for that, it just interferes with the behavior of that specific insect, that there's no impact on other beneficials, for example?
Yes, these substances are so specific that they really often, sometimes they even target just a subspecies, so and we know that because of how they work, and that's why you can have these different provisions for the registration, is because you know that they are so very, very specific, and they're not just specific in the composition, but they're also specific in their threshold, that you have a point at which you have no effect, and then you have the effect, and that's it. Changing dose doesn't change that, so this is why they're raised and saying, actually, you can have really quite a different approach to these substances.
No, very good point. Thank you. And I've also asked for anyone with experience of regulation of semiochemicals. So as an applicant or a regulator or decision maker, if you can share any experience in the chat, that would be interesting as well. If you think if you're quite comfortable as a regulator, as we've just discussed, not potentially asking for or a whole lot of studies that may not be needed based on a risk assessment, then please share that with us. Or if you feel like you need to do more work or increase your understanding, we're very keen to hear that too. Okay, thanks, Roma.
Yeah, no, that's great. And so as well as the FAO guidelines I've looked at, there are also other OECD and EU guidelines for semiochemicals. And what's in those guidelines is a calculation for background levels. So the applicant will put together a reasoned case based on these standard calculations to explain what exposure there would be on background levels. And it's very clear that there's certain types of ways in which the semiochemicals are used do not require, and they're sort of saying, look, if you're using this way, you really don't require residue data and you don't require human tox data. So they're useful, and I provide links to that, and Putra will very kindly also provide these resources to you. So I'm starting now to sort of summarize, and because I want to leave space for us to have a discussion, because I've covered a lot, and it's also quite complex because it's quite such a different approach to what we're used to for conventional chemical pesticides. So starting to sort of sum up and sort of saying, one of the things we don't want to do is we don't want to make registration a barrier. We want to assess these substances in the appropriate way for appropriate dose substances in a way that doesn't take longer, doesn't add to it, significantly increase the costs, and ideally by the applicant and everybody having the right knowledge, that there's nothing to stop this being a fast track process. So what helps with it being a fast track process is having evaluators who understand bioprotectants. It's by having a high level of expertise. So as an evaluator, you may have general knowledge, but you have a team of people you can call on who have the specific expertise that you want to ask for certain things. Really clear process right from the beginning, and very strongly encourage dialogue, because I often see, applicants who've gone away and done test X, Y, and Z and going, it doesn't make sense based on your active substance why you did all these studies. I can't see your logic. So again, as an applicant, think very carefully about what you're trying to do, and then speak to the evaluators and say, look, this is the approach I'm taking, these are the reasons I'm taking it, do you agree with this approach? And what we're not trying to do is we're not trying to provide all the possible information we could about the substance. We're trying to provide the information that allows us to make a risk assessment and then a hazard evaluation. Trusted engaged partnerships, sort of perhaps you're working as a team, so you may have certain expertise in one country and somebody else has got expertise in another country, but working together to share that expertise, because you may not get enough dossiers for everybody to become equally expert. So share knowledge and work with each other, and to have a sort of a harmonized approach that you're all agreeing on the kind of data that would come forward, and sharing of data. If you've gone to the trouble of assessing something in one country, can a nearby country automatically have reciprocity of if not all the data, the majority parts of the data? So maybe they don't have that for efficacy, although you can do that, but you would say, I don't want to do any more animal testing, so we'll accept the evaluation made in another country. And what also helps at government level is to have innovation enabling policies. And what I mean by that is to have resources available to help the evaluators get the training they need to work with these dossiers that are coming forward, be aware of what's going on out there in the industry, because right now there is so much happening, there's a lot of innovation, it's really hard to keep up. And so evaluators, if you're so busy on your day-to-day basis, when do you have time to learn something new? And it's saying to government policy makers, saying that there should be enough space for their experts to gain new knowledge. Okay, and just to say, I mean, I find it really exciting, but gosh, there's a lot of stuff we need to know. And yeah, we do need a little bit of chemistry, but there's a lot of other things that we need to know. So on the end of this slide, this presentation, there's some resources. I'm going to work with Mitra as well to provide more resources to make these available. And I would like to finish there. Thank you very much. And I'm really open to questions and dialogue, and shared experiences would be great.
Great, Roma. Before you move, just keep your slides on for now, because I just want to go back. You had a slide up before. You're getting some feedback already. Just go back a little bit more, and one more. When you had that sort of summary of the sort of things that here, successful bioprotectant regulatory capacity, and you have the list of sort of things that go towards that. You had an example, I think, last week of a country that had developed a specific bioprotection capability, a regulatory policy framework. What works well? I mean, using that example, but other examples, where are some good examples that show case studies of these things in action that some of our listeners today could kind of look at and say,
there's certain countries have sort of recognise that these are completely different substances. So the really good example is in Kenya. So in Kenya, there's a very strong horticulture industry, and horticulture growers were being driven to reduce the chemical pesticides they used in their systems, and they wanted to establish integrated pest management approaches. So the growers called on the government to have a bioprotectant or biopesticide, as they call it, specific registration. So what they did was they brought together scientists, policymakers, regulators, applicants, and innovators together to see, can we develop a new regulation? And they did, and they have a regulation. They've got a pathway for microbials, for botanicals, chemochemicals, and in their case, macroorganisms. And in that, it's what they're asking for is this reduced data set, where the data they're asking for focuses on what you need to know to make a risk assessment, not everything you need to know. It's published. You can get that from the PCBB, which is the Kenyan regulator website, and it's a really good guidance. But that was what now happens is that evaluation process goes very fast in Kenya. So applicants going in and coming out, you're talking in some cases less than a year for that whole process to happen. And they have these pre-submission meetings and that dialogue right from the beginning. Excellent. And that's one of the keys. Yeah, it's a really good example.
Yeah, and I don't know if the representative from Malaysia would like to talk, but I know that they gave some good examples and some good ideas last, and have been on active this session. If you would like to speak, it would be great to hear sort of what your system is in Malaysia. So feel free to put your hand up. And anyone else who, if you'd like to put your hand up and ask a question, please do so as well, because I can unmute you. And so the reciprocity, I'm not even going to say this properly.
Second from the bottom, reciprocity of data.
Reciprocity. Oh my goodness, it's one of those days at the end. I mean, you were saying that potentially could happen between countries on some in some areas.
So yeah, an example I think there is if we think about, so I was doing some work with Caribbean countries and regulators, and you've got limited resources, so you maybe get one dossier a year or two dossiers a year on this, and why assess it from the beginning? But if your neighbour's already assessed it, if you've agreed your data standard between the two of you is the same, then if they've made an evaluation, you can just accept the conclusions of their evaluation into your country. And that's what I mean by the reciprocity of data. Instead of every country building all the expertise, maybe it can be thought about in sort of a regional basis, that some countries have expertise here, some have it here, some have it here. And then okay, if they've done this, they're a specialist in this substance. So therefore I don't have to reevaluate the data. I trust what they've done. and
Yep.
I can use their data.
Yeah. A question back here from Cyril was it was a little while ago, and it's potentially related to, I guess, a broader discussion around semiochemicals, but he was just noting that some farmers reject some semiochemicals because the issue of the proper distance on installations, because there often needs to be quite a careful distance between, you have to have a certain amount in a certain area. Is this applicable? Does distance matter or anything in the regulatory process?
Only in the sense, as a regulator, you want to ensure that the product is label reflects the correct way to use the product. So I think I said, if you think about a semiochemical means that the insect that it's intended to, whose behavior it's intended to affect, has no, there's no response. And then you get to a certain threshold where it can detect it. It's like, you know, if you're cooking, you maybe not be able to smell any of the spices until you've got a lot of spices, and suddenly you can smell them. It's the same for an insect. At a low level, they don't smell them. They only smell them when it gets to a certain, or detect them when it gets to a certain point. So if you haven't, you like to think, oh, I'll save money, I'll put as half as many dispensers out. It won't work because you're not hitting that threshold level. So you need to get everything to that threshold level to get that response, and then you get all of your response, and it all happens at once. So semiochemicals, you can't, and most of our pesticides, you can't dilute, you can't change, you can't reduce. You've really got to work the label. So the evaluators would be looking at that and would be saying, okay, this is what the label needs to say because I've got the evidence that this is what works. And if you deviate from that, we can't guarantee it works.
Yep. Okay. Now this goes back to a little bit you were talking about before, and it's around maybe around the semiochemicals when we started talking about that. Is in what aspect is it difficult to assess on a landscape or field scenario?
That's really difficult. That's what, and because it's really expensive, it's really hard to do. You know, you're thinking if each of your trial plots is, you know, a couple of hectares, that's a really expensive project to do. So what you have to think about is not thinking about standardized replicated trials. It's thinking about how you can adapt that, and you're taking mini samples. So you maybe set up one orchard and do that really well, but monitor it very, very well and get a lot of data out of that. Because it's too costly as well. But you know, things like your plots don't have to be the same size. You can have different size plots if you can justify that. So you've maybe got a bit of forestry here, and of course your treated have got to be a long way from your untreated, otherwise the plume and or pheromone will move across into your untreated plots if the wind direction changes, for example. So you have to think really carefully about how to do those trials well.
Yeah. Now, Roma, you know, I know you've got lots of experience in this industry and in this area of expertise. So when applicants come to you, or they want to be applicants, I guess, what are some of the, if you had to sort of summarize, what are their biggest problems? What are the most common problems that they come to you with and say, look, I really need your help?
Yeah, sometimes applicants come to me because they've been to the evaluators, and the evaluators say you have to go away and think about it. So yeah, ideally they've come to you right at the beginning. So what I tend to think is people, they're often very enthusiastic scientists. They've developed their technology and they know a lot about it, but they really forget to write down that information. So they're going, yeah, but it doesn't do this. And going, you can't just say it doesn't do this. You need to give me the proof that it doesn't do this. So I need those papers. So I think the biggest thing I see is the applicants don't explain well enough what their active substance is, what it does. And that's not just them explaining, they don't present sufficient evidence to explain that well. And they don't explain it in a really consistent way so that the evaluator is able to understand it. And then the other part that they do is they run away and do tests because they think they have to. And I'm looking at a dossier and saying, well, you tested this, this, and this, but that doesn't help me make a risk assessment. It's just a study. So it's, yeah, so I'd say to the applicants to be good at putting on paper in a clear and reasoned way what you know about the active substance. And also, don't rush off to do regulatory studies so they'll run away and do studies and then they change their active substance, saying those studies are no longer any use. You should only do the studies once you've really established exactly what your active substance is, you've characterized it properly, you really know what it is, and then go do the studies.
Good advice. And now I'm going to ask you from, I guess, your experience of running workshops and talking to regulators from the other side. What do you think is their common sort of big things?
The applicant's writing not applicable. You just cannot write not applicable. You have to explain why it's not applicable and provide the evidence why it's not applicable. I just so see that all the time. And again, so embedded in a knowledge, you're saying you haven't explained what you've done or why you've done that, and that's really frustrating. Or seeing studies, you think, well, you did all this animal testing, but you didn't need to, because the microorganism doesn't grow at mammalian body temperature. You could have just done a growth study and not done all the animal testing. Yeah. And it's really frustrating as an evaluator to sort of saying, you're making me read information, read data that isn't going to help me make a good risk assessment. So sort of as an applicant, don't just throw everything at the regulator. Think about it. Think about what information that you should be putting down, and think about how that relates to the characterize what your active substance is, and really explain what's that active substance as well, and give them nice, clear information and all the evidence to help them make their assessment.
That sounds great advice. I actually got somebody who has their hand up here, Yusuf. I don't know if you want to speak, but I'm going to unmute you anyway. If you'd like to ask a question to Roma, please do so. You should be able to unmute yourself. Does that work?
It was unmuted and it's gone back to be muted.
I'm going to do it now. Yusuf, can you unmute yourself now?
There we are. Hi, Yusuf.
Did you want to ask a question? Maybe not. Sometimes we do. That happens. It's pretty easy to accidentally put up the wrong thing sometimes. But if you do, please do unmute yourself. But we're almost actually at the end. What I wanted to do, Roma, is if you just go to the last slide where we have sort of showing what's up next. Here we go. So part 3 is on Wednesday, the 1st of June. We're taking a week's break. We're actually having a specific research discussion next week. But we've now done part 1. We've done part 2. We're on to part 3 at the next session. And what I would be keen to talk to you, just Roma, if you could just give maybe a quick kind of brief overview. What are we going to be talking about in the next session?
Yeah, so this is sometimes the sort of more complicated part of the dossier is, so what happens in the environment and what effects they're going to have on non-targets. So if we're thinking about microorganisms, we know that the environment's really full of microorganisms, and it's just sort of thinking, well, okay, if it's really full of microorganisms, what information do I need to provide? What's happening to my microorganisms when it's go out there? And a botanical, like we talked today, saying that for botanicals, you know, if they come from plants, they're commonly found in plants. What's happening in the environment with these substances? And then that idea, we've had some questions already for the non-target organisms about the specificity of the active substance to its host. What happens, you know, what happens if a bird eats an insect that's been infected with a microorganism? What happens then? How do you assess that? So we're just sort of unpicking and pulling those parts of it. So I'll talk first about the environment and what happens in air, water and soil, and then sort of say, okay, in those environmental compartments, what organisms have you got there, and what happens to those organisms in those environments, and where should we be concerned, and where can we get sufficient information that we realise we don't need to be concerned.
Okay, great. Thanks, Roman. That sounds exciting. I'm really interested in that. And I'd just like to thank you for today's session as well, and of course last week's session, and just to everyone for joining us. Fantastic to see so many people again online. Just shows the interest out there. And what I'm going to try and do is when I send you the recording of this session, and I'll resend the recording from last session and the PDF copies, I might just ask you to, if you can, just spend like 3 minutes just to go into a SurveyMonkey monkey poll or something, and I'll just leave a blank space for any, like 3 questions. If you have 3 questions you'd like to have answered in the last session, if you could take the time just to write those down, and then we will try and I'll pass those on to Roma, and it'll be anonymous too, so you can ask any question you want without fear of being associated with the question. So definitely no silly questions. They're all good questions, and if you could take that time to do that, that would be great, because I think that would be a real learning experience.
Oh,
and then
really
Roma,
good.
then Roma can kind of also spend a bit of time on making sure she answers those questions that just don't get asked sometimes, and it's a burning question that you need to know. You've got great feedback in the chat, and I'm just really not surprised. I'm going to give you a reaction to Roma. So thank you so much for such a great session. Thank you for everyone for joining us again. We'll see you in 2 weeks' time on Wednesday, the 1st of June, same time, but on a Wednesday rather than a Tuesday, just to mix it up a little bit. And thank you very much. Keep safe, everyone, and we'll see you soon.
Thanks everybody for joining today. It's really great.
Thank you. Thanks, Putra.
Look forward to all those questions. Yeah, thanks, Putra. I think we've got a lot of information to put together.